Hello, everybody. Let's see if I can do this any better. Hello, everybody. Got a little bit better at that. How is everybody? I am going to record for you here a quick refresher video on perimeter and area. This is something you've been working with for 2 years now. I just need to make sure that you've got a good, clear understanding of it for today's work. Perimeter, the difference between perimeter and area. Perimeter. The perimeter of something is how far around it is, right? If I was, if this was our base, and a soldier was told to go walk the perimeter, he's being told to go out here and walk the whole edge of the fence and make sure there's nothing going on. He's going to go walk this one. He's going to walk this whole fence, this whole fence, and this whole fence, and then he's going to come back and report. He's not going to walk this fence and then stop, because if he was told to walk the perimeter, he was told to walk the entire outside edge. Another way of thinking about perimeter is if I were going to wrap a string. If I were going to take a piece of string and wrap it around this so that it worked out exactly right, I would need to be able to start at one corner. I would need to be able to wrap that around, and then it would go around here. Then it would go here, and then it would go here. And I would cut the string right there. Perimeter would be asking how long. If I took this string and then stretched it out from start to finish, how long would that string be that was wrapped all the way around the outside edge? These are all just ways of thinking about perimeter, but it's important to understand what it does and doesn't mean. The other thing that we need to talk about today is area. Area is a very specific idea. Last year you learned that perimeter was the outside, area was the inside, and while that is true, for fifth grade we need to have a more detailed understanding of what that actually means. Area means how many unit squares it would take to fill the whole area in. If I were to have centimeters, right, if this was 2 centimeters long, that would mean that this would be 1 centimeter and this would be 1 centimeter. If this is 3.5 centimeters long, it would be 1, 2, 3 centimeters, and this is a half a centimeter, right? This means that I could, if I were to fill this in with 1 centimeter squares, I would have 1, 2, 3, 4, 5, 6 centimeter squares that are centimeter on the side, and then I'd have these 2 half centimeters, which would add up to a 7 centimeter, okay? Area and perimeter are very different things, which is why they have very different units. Perimeter is measured in a linear unit or a straight line. For example, this is a straight line. This is a linear unit right here, 3.5 centimeters. That is a straight line, 3.5 centimeters long. I can measure that with a ruler. If my perimeter is a straight line, then it has to have a straight line unit. In this case, they're going to be centimeters. I'm yet to figure out how many centimeters, but I know that its units are going to be in centimeters, right? Because it's a perimeter, I have to have a straight line unit. Area, though, to find the area, I'm going to be taking the length times the width. I'm going to take this 3.5 centimeters and I'm going to multiply it by 2 centimeters. So I'm going to end up with 2 centimeters multiplied together, which is why we call it centimeters squared, right? I could also write that as centimeters squared if I like, or you can write square centimeters. All three of these are correct. This is probably the most easy to use one, centimeters with a 2 in the exponent, but you can write centimeters squared and you'll be understood just fine. What you can't do is multiply 3.5 centimeters by 2.2 centimeters and come up with a unit that is just centimeters, because that's a linear unit. I need these square centimeters, so I can say how many of these centimeters squares it would take to fill in the space, to fill in the area, right? So now that we've talked about this, let's see what it looks like in practice, right? I'm going to get some of this stuff out of our way. I don't know, maybe I'll get fancy and delete this bit out, who knows. Okay, let's start with perimeter. If I'm going to find the perimeter, let's see, let's go back to black. If I'm going to find the perimeter, that means I need to know I'm going to start here and I'm going to go across here, and that is going to be a distance of 3.5 centimeters. So I've got 3.5 centimeters plus. Now from here, I'm going to go down this side. That's 2 centimeters, so it's going to be 2 centimeters there. Right? Then from there, I got to go all the way back across this long way again. And that is 3.5 centimeters. 3.5 centimeters plus, now to finish, I got to go all the way back up here so I'm where I started. And that side is 2 centimeters. So in order to, move this down here. So in order to find the perimeter, I have to add 3.5 plus 2 plus 3.5 plus 2. Well, if I come over here on the side, 3.5 plus 2 holes. When I'm adding, I have to line up my decimals. That is 2 holes. If I put the 2 there, then that's only 2/10, right? Plus 3.5 plus another 2 holes. And that's my addition problem. I'm going to get, let's see, 5/10 plus no tenths plus 5/10 plus no tenths, that's 10/10, right? So 5 and 5 is 10 tenths. And my decimal stays there. 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. So I get a perimeter of 11. Now what's my unit? These aren't square units. This is not cubic units because we're not doing volume, we're doing perimeter. It's a straight line, so I need a straight line measurement. It's 11 centimeters. That's a perimeter, okay? Now for area, I need to do length times width. So I'm going to take my length, which is 3.5, times my width, which is 2. You know what? I'm going to actually be real explicit with this. I want to show you exactly what is happening. I'm not going to leave anything out. This is 3.5 centimeters, right? And we're going to multiply that by 2 centimeters. So for our decimal multiplication, remember we ignore the decimal into the end. For now, we're going to pretend we don't even see that decimal, and we're just going to multiply 2 times this 3, 5. So 2 times 5, that's 10, and the 1 carries, goes to the next column. 2 times 3 is 6, plus this 1 is 7. So I've got 7 0, but I need to decide where my decimal goes. How many decimal places do I have in this number? Well, a decimal digit is just a number to the right of the decimal. This is a whole number. This is a decimal digit. So I've got 1 decimal digit here. Do I have any decimal digits in the 2? No, I don't have any. These are all, 2 is all whole numbers. So I've got 1 decimal digit total. So my answer has to have 1 decimal digit total, which means my answer is 7.0. Now my unit, I can't forget my unit. My unit is actually centimeters times centimeters, or centimeters squared, right? So my area, the answer to area is going to be 7 centimeters squared. Now, if you look up here when we did this example, that's exactly what we did. It found, isn't it? I had one, 2, 3, 4, 5, 6 whole 1 centimeter squares, and then I had these 2 half centimeters over here, didn't I? And the half and half is 1, so that adds up to 7. But you don't have to do the model. I just wanted you to see where we were getting that from. I mostly want you to understand that a centimeter and a centimeter square are very different things. They aren't even close. So this is 11 centimeters. That's a straight line measurement. This is 7 centimeters squared, or 7 square centimeters. That's an area measurement. Okay? Let's take a look at another example. Here's another example, very similar to what we would have in our lesson today. For this, I need to find a perimeter. Let's see. Perimeter equals. Let's find a perimeter on this one. The perimeter is going to be, if I go across and down and over and back up again, what would that add up to? Perimeter, I'm always going to be adding. So I'm going to have across the top is going to be 12. And down the bottom is going to be 20.25. Now that's 20 holes. So I have to line it up under my holes. That's 12 holes and 20 holes. And this 0.25 goes out here in the tenth and hundredths place, right? Then I need to come across the bottom. Again, that is still going to be 12 meters. So I've got another whole 12 meters here. And then I got to come back up the top the long way. And that's going to be another 20.25 meters. 20 holes. And then 2/10 and 5/100ths. If I add that up, I get 5 and 5 is 10. The 1 carries. 2 and 2 is 4, plus 1 is 5. And that's it for my decimal digits. Now I'm going to go over to my whole numbers. 2 and 2 is 4. And 1, 2, 3, 4, 5, 6. So I get a total perimeter, a total distance around this shape of 64.5 meters. Not square meters, not cubic meters, but just regular old meters, because that's a straight line. If I took a string and wrapped it all the way around here, I could stretch it out in a straight line. It would be equal to 64.5 meters. Okay? Now for the area. That's the fun part, right? For area, area is always going to be length times width. So we're just going to multiply our length by our width. What is our length? I'm going to call this 12 meters, my length. This is 12 meters times, you know what? I'm not going to do that. You know why? It'll work either way, but I find it's easier to put the bigger number on top, just because it means I don't have to write as many lines. I'm actually going to take that larger number of 20.25 meters, and I'm going to multiply that by 12. See why I did that? If I did it the other way and put this in the bottom, it would still work, but I wound up with 4 partial products to add up, and this way I'll only have 2, right? At the end of the day, I don't like to do extra work any more than you do, right? So now we're going to multiply again. We pretend that that decimal isn't even there. We don't worry about the decimal until the end. For now, I've just got 2025, and I need to multiply that by 12. Let's start by multiplying the 2. 2025 times 2. 2 times 5 is 10. Carry the 1. 2 times 2 is 4, plus 1 is 5. And I'm going to cross that out because I already used it. 2 times 0 is 0. And 2 times 4 is 4. Now I'm done with the 2. Now I need to multiply 2025 by this digit right here. What is that? It is not a 1. It's a 1 in the tens place, which means it's a 10, isn't it? That's 10, not 1. So that means I need to do 2025 times 10. The good news is anything times 10 is going to have a 0 on the end, isn't it? We know the last digit's going to be a 0. So if I put the 0 there now, I could just call it a 1. 1 times 5, 1 times 2, 1 times 0, and 1 times 2. If I add up my two partial products, I get 0 plus 0 is 0. 5 plus 5 is 10. Carry the 1. 2, 3, 4, and 2. Now, my answer has the digits 2, 4, 3, 0, 0. But I need to figure out where the decimal goes. So let's go back up here to our problem. How many decimal digits do I have? Let's see. I'm going to choose another color. And I'm going to underline the decimal digits. Decimal digits are just any digit after the decimal. So these numbers before the decimal, those are wholes. These numbers to the right of the decimal, those are decimal digits. So I've got 1, 2 decimal digits. What about down here? 12 is whole. Do I have anything behind it? No. So I have a total of 1, 2 decimal digits. My answer has to also have 2 decimal digits. So my decimal is going to go right there. So that makes my answer to the area of this problem. The area is equal to 243. Now my units multiplied a meter times a meter, that's square meters. That means that if I had some giant squares that were 1 meter on a side, it would take 243 of them to fill in this whole space. Isn't that crazy? Areas get big fast, right? But that's how we do area. Now there's one other kind of problem you're going to see, and that's something like this. Look at this gorgeous beast. I got all kinds of stuff going on in this one. Yeah, I've got a rectangle, kind of. I've got another piece over here, but it's made up of rectangles, so we should still be able to find the area and the perimeter. Let's start with perimeter. I'm going to put this up here out of the way so it can't hurt anybody. And then we are going to go ahead, go back to black, and I want to make my dots a little bigger. I think that'll trick you into thinking I got better penmanship than I do. Come on, you can do this. There we go. All right. Now let's start by finding the perimeter. Perimeter equals. Now, for the perimeter, just the same, I'm imagining if I were to take a string and wrapping it all the way around all these edges, right? I would have to do all of these sides. So let's start right here. I'm going to start right there. If I go from there, black is not a good choice. Let's try green. If I start there and I go from there to there, that's 9.25 inches. So that's 9.25 inches, right? Now if I come down this way, how far is that? There it is right there, 7.25 inches, right? What about across here? It doesn't tell me. How can I figure that out? Well, I know I've got the whole thing, across this whole thing is 16 inches. And this much of it is 9.25. So this and this would have to add up to 16, wouldn't they? From there to there, and then from there to there would have to add up to 16. Here, I'll make it a little easier to see. This from here to here plus from here to here would have to be the same as this, wouldn't it? So If this much is 9.25, how far is this? Don't make me draw a tape diagram. You know I'll do it. Okay, fine. You don't believe me? Watch. Look, here's my hole. What's my hole? My hole is the big one, right? 16. And I got two pieces of it that have to add up to 16. One piece is 9.25. And I got to find that piece. That piece is what will go there. So how can I find that? What's that in the back? Yes, subtraction. This, to find out what this has to be so these can add up to there, I need to take 16 and subtract from it 9.25. We're adding, because of the invisible box, everything we can only add and subtract things that are the same. So we have to make sure our ones and our ones are added up or lined up, our tenths and our tenths are lined up, and that's why we have to line up the decimals. Now let's subtract. 5 from 0. Nope. I have to go all the way over here to get some. I'm gonna take 5 holes. I'm gonna take one hole, leaving 5, and it's gonna come over here and add to the 0 and make that 10. Then I can borrow 1/10 and bring it over here and add it to the 0 and get 10 hundredths. Right? So 5 from 10 is 5. 2 from 9 is 7. 9 from 5 doesn't work, but 9 from 15 does. That's going to be, what, 6? So that means that this part right here has to be 6.75 inches, so that this part and this part can add up to 16, right? So now I know I did this part and this part. Across here is going to be 6. Across here is 6.75 inches. Okay. Now we got to keep going though. We have to go down this side here. We know that's 4 inches. It's 4 whole inches. So the decimal is there. And then across the bottom the long way, that's just 16 inches. That's 16 whole inches. I'll put these zeros in here because Mr. Sexton's lines are getting a little bit wobbly there. I got to try and keep those clean. All right, now I'm going to go from here all the way up to here. But again, they didn't tell me what that is. But how can I figure it out? What have I got over here on the other side that would have to be equal to that? Well, let's see. This side here would have to be the same as this part plus this part, right? Those two together have to be the same as that. So this gives me 7.25 plus 4 wholes. So 5 hundredths plus 0 hundredths is 5 hundredths. 2 tenths plus 0 tenths is 2 tenths. 7 holes plus 4 holes, that's going to be 11. Does that sound right? Yeah, 11. 11 inches. So that means that for these to be what they are, they have to add up over here to 11.25 inches. So that long trek up there has to be, this part right here has to be 11 holes and 25 hundredths. Look at that beast. But if I add that all up, then I will have counted up all the sides. Let's see what we get. 5, and 5 is 10, 5 more is 15, and 5 more is 20. So this is going to be 20. Then 7, 8, 9, 10, 7, 8, 9, 10, 11, 12, 13, 14, 15. And this goes all the way up there. Then 9 and 1 is 10, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. And then 3, 4, 5, 54. Wowee. These are all inches, but we add them up, that's what they are, and 54.50 is how many of them we have. So my perimeter is 54.50 inches. Not inches squared, not inches cubed. We took a straight piece of string and wrapped it all the way around there. That gave me 54.5 inches of string on the perimeter of that wacky shape, right? Now, let's see. Now we need to talk about area. Let's switch to purple. Now, for area, as always, is hold on. This little thingy. Area is length times width. It always will be. But I've got a wacky shape going on over here. Just like with volume, when we had compound prisms that were made out of rectangular prisms, we were able to break them into pieces, find the volumes, and then add them together. We're going to do the same thing here. We're going to look at this as two different rectangles. What if I were to take a knife and cut this right here so that I got part A and I got part B? You see that? Now I can find the area. What's the area of part A? It's going to be 9.25 times 11.25, right? Length and width. So that's 9.25 times 11.25. Let me get rid of that little doohickey there. It bugs me. There we go. That's prettier. All right. Now, again, I'm going to wait until the end. I'm not going to worry about these decimals until the very end. Then I'll count up my decimal places. But for right now, I'm just looking at the digits. 1125 times 925. So I'm going to start with this 5. 1125 times this 5. 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12. 5 times 1 is 5, plus 1 is 6. I've not put in a decimal there. I do not know where the decimal goes, right? 5 times 1 is 5. So 5625 are the digits you get if you take a 1125 times 5. And we're done with that. Now we need to put a 0 there. So we can call that just a 2. 2 times 5. Wait a minute, before I mess myself up, I'm going to scribble those out because we already used those. We don't want to use them again. 2 times 5 is 10. 2 times 2 is 4, plus 1 is 5. 2 times 1 is 2. And 2 times 1 is 2. Now I'm done with that. Now, this is a 9, but I got 2 digits behind it, so I need 2 zeros. Because really, I'm going to call that a 900, right? 9 times 5 is, that's 45. Carry the 4. 9 times 2 is 18, plus 4 is 22. 9 times 1 is 9, plus 2 is 11. And 9 times 1 is 9, plus 1 is 10. Look at that beast. Well, let's add it up. 5, 0, 0 is just 5. 2 and 0, 0 is just 2. Then I got 5 plus 5 is 10, plus 6 is 16. 5, 6, 7, 8, 9, 10. 2, 3, 4, 0, and 1. Wow, look at all those numbers. Now and only now can we start thinking about where the decimal goes. So let's go up here to our original 2 factors and let's underline the digits that are in decimal digits. So this over here, this is 11. Those are whole numbers. That's a whole 11 inches. This is part of an inch. This is 1, 2 decimal digits. Now let's go down here. This is a whole 9, decimals there. So after that I had 1, 2 decimal digits. So how many decimal digits do I have my factors all together? 1, 2, 3, 4. So that means that my answer has to have 4 decimal places. So my answer for the area of A is going to be 104.06 square inches, right? Because that's square inches. That means that if I had little squares that were 1 inch by 1 inch, 104 whole ones would fit in there, and a little sliver, 6/100th of another, would fit to fill this whole space in those squares, right? That's what area means. But now I got to find B. What about B? Well, let's see. We'll do B in yellow. Okay? B is this part right here. Well, our area is, as always, is going to be length times width. So my area of B is going to be 6.75 inches times 4 inches. And there's nothing for it but to do it. Let's go 6.75 times 4. Let's see what we got. Ignoring the decimal till the end. 4 times 5 is, that's 20. 7 times 4, that's a tricky one. 2 4s is 14. I'm sorry, 2 7s is 14. So 4 7s must be 2 14s. That makes it 28. 7 times 4 is 28. Plus 2 is 30. 4 times 6, that's 24. Plus 3 is 25, 26, 27. So I've got 2700. Now let's figure out where our decimal goes. Again, let's underline in red the decimal digits. Well, 6 is a whole number. Then we had our decimal. And then after that, we've got 1, 2 decimal digits. If we get on to my other factor, I've got 4. That's a whole 4 inches, right? So the decimal goes there, but there's nothing behind it. So there's no decimal digits there. So total, I have 1, 2 decimal digits. That means my answer must also have 2 decimal digits, which puts my decimal there. The area of section B is 27.00 square inches. Now, I need to know the total though. The total area equals, it's going to be 104 0.06, and we're going to add to it the 27 square inches. This is, let's do it like this, inches squared. And we're going to add them up. 0 plus 6 is 6. 0 plus 0 is 0. 7, 8, 9, 10, 11. 3, and 1. So the total area of this whole wacky shape is 131.06 square inches. Boom. Look at that. What a beast. It was a lot to it, but we took it one step at a time, and we were able to find all the things we needed to know about that shape. Okay? Now, if you have any other questions, come see me during office hours between 10 a.m. and 11:30. The Google Hangout will be open at that time. Just come to me through Canvas, and I look forward to seeing you. Talk to you later, guys.